Students, today we will discuss the Fourier series method. This is the basic formula in we use Fourier series, where u and v are both the functions of x, and u is an algebraic function like x, x square, x e2, and so on. If we integrate their product, that is u dot v integrate with respect to x. In this case, u as it is, and the differentiation of v negative of and integration of first, differentiation of second, plus integration of u again and differentiate v again and dot up to. And all the terms having alternate sign, that is first term is positive and second term is negative, third term is positive and again is negative, positive. And where u and v are the functions of x. So here we will define a Fourier series of a given function. Suppose this is a function which satisfying all the discrete conditions, and suppose interval is c to c plus 2 pi. This is the first case interval where the function fx defined in an interval c to c plus pi. There are three cases arise in which c may be 0, minus pi and so on. So if we define the function fx Fourier series in the interval this, so this is the expression of Fourier series. This is fx is equals to a naught upon 2 plus summation of n equals to 1 to infinity and an cos n x plus summation of n equals to 1 to infinity and bn sin n x. So this is the expression of a Fourier series of a function fx. This is defined in interval c to c plus 2 pi, where a naught, an and bn are the Euler's constant, which is evaluated by the given formulas, where this is a naught. Denote simply 1 upon pi and the given range of interval. This is c to c plus 2 pi, this is c to c plus 2 pi, and the given function f of x of dx, and then an, this is an is equals to 1 upon pi, and same range of interval. This is c to c plus 2 pi fx into cos nx dx, and the last Euler constant, it is bn, which is evaluated by 1 upon pi limit c to c plus 2 pi and fx into sin nx and their dx. In this case, function fx is given and c may be 0 and minus pi, given function and the given corresponding interval, which is length 2 pi. If we find the limit, this is c plus 2 pi and minus c, so this is c to c cancel, and the last length of interval is 2 pi. So first, in this case, we find Fourier series which having length of interval is 2 pi. So these are the basic formulas in which all the values of c are changed, either this is 0 and the pi. So there are two cases arise in the case first for the Fourier series. First case is when c is equals to 0. This is case first when c is equals to 0. Then in this case, all the formulas are converted into simply this is 0 to 2 pi and this is 0 to 2 pi and this is 0 to 2 pi. In this case, all the a naught, an and bn find with the help of this formula and then putting a naught, an and bn in the expression Fourier series. This is fx. So in this case, a naught is converted into simply 1 upon pi limit 0 to 2 pi, and this is fx dx, and second is an 1 upon pi limit 0 to 2 pi, this is fx and dx, and last Euler constant students 1 upon pi limit 0 to 2 pi, this is fx into sin nx into dx, this is fx of cos nx dx. This is the first case when c equals to 0 and all the other constant students converted into 0 to 2 pi, 0 to 2 pi and 0 to 2 pi. And second case students, case second. Case second when c is equals to minus pi and c equals to minus pi. In this case students, this is minus pi plus c minus pi, this is 2 pi, so this is minus pi plus 2 pi, so it is converted into this is interval minus pi to plus pi. This is the interval in the case second. In this case, all the Euler constants convert into simply a naught is equals to 1 upon pi. So here this is c to c plus 2 pi. That means the given interval range of interval. So here the given range of interval is minus pi to plus pi. This is minus pi to plus pi, and function as it is, this is fx and dx, and bn is equals to 1 upon pi minus pi to plus pi fx into cos nx dx students. And next, sorry, this is an, and then bn is equals to 1 upon pi minus pi to plus pi. This is fx into sin nx dx. So in this case, students, when c equals to minus pi, there is a benefit when the definite integration of integration, that is, if function in the given interval may be even or odd. Suppose students, fx is even. In this case, students, suppose function even. Okay. So in this case, function even, then this is minus pi to plus pi. This is also minus pi to plus pi. This is even. This is also even. But this is even and this is odd function. So this is entire function multiplication after this. This is odd function. So in this case, students, bn would be 0. That is, when function is even, then bn is equals to 0 by the definite integration property. And next, if fx is odd function, this is odd function. अगर suppose करिए students, इस केस में function आपका odd हो जाता है. So by definite integration property, this is odd into even. This is also odd. So in this case, this is odd. Also, this in this case, odd into odd is even. So in this case, bn is exists, but a naught and an is 0. That is, when function fx is odd. So in this case, a naught is equals to 0, and a n is equals to 0. So when the function is even or odd, students, and in this case we can easily find either one Euler constant is 0, either function is even, then bn definitely 0. If function is n, then a naught and an definitely 0. So next क्लास में students कुछ प्रॉब्लम्स लेंगे हम लोग, सॉल्व करेंगे फोरियर सीरीज पे. ओके.